think of Kent Clark when he used to go into the phone booth and dress up or change into Superman, right? He'd have his work clothes on, his slacks and his shirt and his tie and his jacket, and he was all suited up, business casual or business, to go into the photo booth, to the phone booth to change. Well, what if he just changed the bottom and then he put on a Batman shirt? He multiplied by 3. He did something totally different. Is that what he did? No. He was Superman on the bottom, so he changed his bottoms, and he was Superman on top, so he changed his top. So the same thing you do to the bottom, you do to the top, just like a superhero. You don't see them mixed-matched, a Batman and Superman, or any others all mixed-matched. Okay? So here we have 2 times 2 is 4. Whatever we do to the bottom, we have to do to the top. What is 1 times 2? 2. What did I do? I multiplied by 2. Okay? Let's go ahead. Let's take a look at number 6. What do I do to 3 to get to 12? Let's count by 3s. If you have your multiplication chart, you can look at your multiplication chart, find the 3 on the top or on the left, go across or down till you see the 12, and then go up or to the side, and what number is it? Let's find out. 3, 6, 9, 12. How many times? 4. So 3 times 4 is 12. Whatever I do to the bottom, I have to do to the top. I multiplied by 4. What is 1 times 4? 4. Okay? Good deal. Let's go ahead and take a look at, let's see, we've done our multiples of 2 and 4. Let's look at number 11 on the bottom. And this on number 12 is an equal sign. But let's take a look at number 11. What do I do to 2 to get to 10? 2, 4, 6, 8, 10. What did I do? I multiplied by 5. Whatever I do to the bottom, I have to do to the top. What is 1 times 5? 5. There you go. Equivalent fractions. Let's take a look at number 1. Leonard bought a poster board and cut it into 4 equal pieces. Leonard used 3 of the pieces to make his display for his science project. Which fraction is equivalent to the amount of poster board Leonard used? My key here is to always draw a picture, starting with the first sentence. So I read my problem, underline the question, which fraction is equivalent to the amount of poster board Leonard used? Okay. First sentence. Leonard bought a poster board and cut it into 4 equal pieces. So I'm going to draw my poster board. He cut it into 4 equal pieces. When you're dealing with fractions, you're either going to cut vertically or horizontally, not both. Okay? And you'll see why in just a minute. So we have 4 equal pieces. I'm just going to narrow it down, eyeball it. There's half, and I'm going to cut those in half. So I have about 4 equal pieces. Okay, you just kind of got to estimate there, or guesstimate. So we have a poster board. Perfect. I cut it into 4 equal pieces. Yes. Leonard uses 3. How many? 3 of the pieces. Well, here I have what? 1/4, 1/4, and 1/4, and 1/4. But he only uses how many pieces? 3 pieces. So 1, 2, 3. for his display. This goes in the trash, stays at home, whatever you want. But this is the pieces that he uses. So how many pieces, how many fourths did he use? 1/4, 2/4, 3/4. He uses 3/4. Now I can look at my answer choices. Which fraction is equivalent to the amount of poster board Leonard uses? I'm going to show you two different things that you can do. You can, looking at the denominator, compare the 3/4 by each fraction, or you can do the multiples of 3/4. So let's take 3 and let's take 4 and let's do our multiples. Let's do times 1, times 2, times 3, times 4, times 5. 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. 3 times 5 is 15. 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. 4 times 4 is 16. And 4 times 5 is 20. If you have your multiplication chart, look on the left-hand side. You know how your I'll do it in a different color. You know how your multiplication chart has the numbers 1, 2, 3, 4, 5, 6, 7, all those numbers going down on the left-hand side? Put your two fingers on 3, 4. Go across. Do you see 3, 4, 6, 8, 9, 12, 12, 16, and 15, 20? I bet you do. So let's take a look. Do we have 3, 6? Do we run into 3, 6? No. Do we have 8 twelfths? Nope, we have 9 twelfths. Do we have 5 6? Nope, we don't have a 6 on the bottom as our denominator. Do we have 6 eighths? Yep, right here, 6 eighths. That's our equivalent fraction. So that's one way to find it. Your multiplication chart, write out your multiples. This is the other way. You're going to write 3/4 to the left. You want the smallest denominator on the left. Write that down. Smallest, I'm just going to put a D. Smallest denominator on left. This is my left. This is my right. Okay? So 4 is smaller, so I put on the side. 3/4, 3/4, and 3/4. Now, can I do something to 4 to turn it into a 6? No, there's nothing. 6 is not a multiple, so there's no way it's A. Can I do something to 4 to get to 12? Let's see. Yeah, I can multiply by 3. All right. Whatever I do to the bottom, I have to do to the top. What is 3 times 3? 9, not 8. So my answer is not B. Can I do something to 4? No, I already figured that out on A. There's nothing I can do to 4 multiplying to get to 6. And what can I do to 4 to get to 8? Multiply by 2. Whatever I do to the bottom, I have to do to the top. What is 3 times 2? 6. Correctamundo. Some of you may say, oh, well, I can add 2, right? But no, no, no. Equivalent fractions are multiples of each other. That needs to go in your notebook. Equivalent, it's right here, equivalent fractions are multiples of each other. Equivalent fractions are multiples, so that means you have to multiply by something. Okay? Let's see. So here you have 4/5. It's a small denominator. It's going to go on the left of every fraction. Let's see. 3, 4 look pretty okay. And I think you've got the rest. If you have any questions, please let me know. And that wraps up our equivalent fractions packet. Alrighty, have fun. Good luck.